Welcome to qnawire.
In this problem, the first thing that we have to do is find the centripetal acceleration of a ball being rolled around in a circle. Now, as usual, we start with our equation for centripetal force, mv squared over r. Now, we're not given v in this problem, but we are given the period, and we know that t is equal to 2 pi r over v. So that can be easily rearranged to solve for v. And since we know the value of t, we can now pretty easily solve. Going back to our original equation for force, when we plug in, we find that Fc is equal to 4 pi squared times r over t squared. And these are all quantities that were given. So when we plug in, we get that our centripetal force is equal to 0.012 times 4 pi squared times 0.1 meters, all over our period 0.5 seconds squared. And I forgot to include the units of mass here. This should be in kilograms. And so we get that our force is 0.189 kilograms meters per second squared, which are units that are also known as newtons. So that's going to be equal to 0.189 newtons, which is our answer for part A. Now, moving on to part B, this part of the question doesn't really have anything to do with the scenario that we're given itself. It's rather just knowing something about the equation for centripetal force. So as we said earlier, that's mv squared over r. And part B asks us if, when we double v, if the centripetal force doubles as well. Well, let's try it. If we have Fc2, I'll denote it, then we would have m times 2v squared over r. Since 2 squared is 4, and if everything else was held constant, we would have 4mv squared over r. So the answer is that no, it does not in fact double, it quadruples. And that is our answer to the second part of the